going through problem number 10. It's different than the other problems on the electrostatic sheet, but I did want to kind of walk through it together. So 10. If you'd like to try it by yourself and then just check my answer, go for that. But I'm going to walk us through. So a pith ball. So remember from oh, actually you haven't seen this because that's going to come up in a later video. So a pith ball is this. It is an extremely light object. It's actually lint coated in metal. Watch, I'm gonna blow there. It's very, very light. And so it could get disturbed and pushed around by even small forces. So we often use it in demonstrations to demonstrate the electrostatics force. So with a pith ball of mass 10 grams, and right away I'm not gonna put up with that. We're just gonna go right to kilograms. And a charge of, okay, so Q is equal to positive 8.0 times 10 to the negative 9th coulombs. Oh, I could have written that how? I could have written that as positive 8 nanocoulombs as well, but we won't get into that. It's suspended by a string. Okay, so here's my pith ball, and it's suspended by a string. A charged object is brought near, causing the pith ball to deflect to the right. All right, so here's my pith ball, was deflected to the right. In the final state, the object is at the same height of the pith ball and to the left of the pith ball, with the string making an angle of 10 degrees to the vertical. So, okay, 10 degrees. And here's my second object. It's to the left of it. When the second object is 10 centimeters from the deflected ball, so apparently this is 10 centimeters. And I want to know what the charge on this second object is. Right, here we go. How are we going to do this? Oh dear. Well, the first thing to note is that this thing is suspended, right? And it's just kind of hanging out there. So what does that mean? That's going to become very important, so hold on to that. But we're going to start these things as we tend to with a free body diagram, because this is all about forces. So here, unlike in the last set of problems, the weight of the object is relevant. Well, why do I know the weight of the object is relevant here? Well, because initially this ball was hanging straight down, so this thing has tension because that's pulling down. I could also tell because this object was given as a mass. That's generally when you know that unless if they're asking for the mass, or if they are given the mass, you know gravity is relevant in the problem. But this would be the sort of thing where you could totally reasonably ask, hey, in this problem, would gravity be a relevant consideration? So here it is. So I've got Fg going down and that tension force going up. Now, notice here that this object was pushed to the right. That must mean this thing is experiencing an electrostatic force to the right, right? Because that's the only way that that could have happened. So I know that this is positive, so I already know that this second charge must also be positive because it repelled, right? So since it repelled, it must be like charge, and therefore Q2 is positive. Boom, so I'm already partly along the way. So there we go. Step 1, free body diagram. Step 2, axes and declaration. I'm going to use my standard Cartesian. I'll say positive y, positive x. Step 3, components. The tension's acting at an angle here, so I'm going to go Tx and Ty, right? Part of our same process. Oh, this should remind us a lot of the hanging sign problems that we did in November. We know that this angle here is 10 degrees. All right. Step 4, side calculations. Okay, well, I could do a side calculation of the weight. So the magnitude of Fg is equal to m little g, and so 0.01 kilograms times 9.8 newtons per kilogram, and that's 0.98 newtons. So that's the weight of the object. I wonder if, can I do the electrostatic force is equal to K Q1 Q2 over R squared. No, I can't, right? Because I don't know this charge. and I don't know the force yet. So maybe the goal here is to find this force so I can find that charge. Well, how else could I find the charge? Well, let's go on with our process. Or how else could I find this force? Let's go on with our process. Sum of forces equation. Okay, so here we go. F net x equals max. I got to do 2 dimensions because I got both x and y going on here. And so positive Fe minus Tx equals max. And I'm just going to do the y equation now because I can just get that set up here. I can go positive Ty because that's acting upwards, magnitude of minus Fg equals may. Now the trick of this problem is this object is just chilling out there. It's not doing anything. It's just hanging out, right? It's in equilibrium. So that means that the 2 accelerations are 0. And here's the way forward. Because that means the magnitude of Fe is equal to Tx. And the magnitude of Ty is equal to Fg. Oh, okay. Well, now I have the way forward, right? So Fg is 0.98 newtons. Ty, if I can find T, then I can plug that in over here to get this, to plug that in over here to get that. All right, here we go. Ty, let's look at our triangle. Ty is on the adjacent side of this triangle. So don't be a sucker. I'm going to use cosine here, not sine, because of how I gave that angle. I gave an angle to the vertical, not the horizontal here, so that kind of messes with our normal geometry. Okay, so I find out that the magnitude of T is 0.995 newtons. I can come over here then, Fe must equal T sine of 10, so it's 0.995 newtons sine of 10. And so, put that in my calculator, 0.173 newtons, and now I come over 1.73 newtons is equal to 9 times 10 to the 9th newtons meters squared, over coulomb squared. We know this is 8 times 10 to the negative 9th, Q2 magnitude over R. We're told that's 10 centimeters, 0.1 meters, quantity squared. Now I can solve this for the magnitude of Q2. So that times 0.1 squared divided by 9 exponent 9 divided by 8 exponent negative 9. And I find out that Q2 is 2.4 times 10 to the negative 5th coulombs. And therefore I know Q2 is a positive 2.4 times 10 to the negative 5th newtons. I did, coulombs, excuse me. I did the analysis up here, and you'd want to have some sort of written analysis every time that you're trying to determine the sign of something so that you can provide the evidence that you need to know. And that is how you do number 10.